We are in the lesson, what is this, 8.4? No. Okay. We left off talking about inverse trig, like the buttons in our calculator. And these are used for when we know what the ratio is, but we're trying to find the angle. So I think the last thing we did in class, we took this one right here. We know that the cosine of 45 degrees is that square root of 2 over 2, that irrational number. And we did this in our calculator. We went backwards. We said, okay, what's the inverse cosine? So when you use this button, you feed in the ratio, or you feed in like the side length, and you'll get out which angle gives you that ratio for cosine. So we did that in our calculator. That was the last thing we did in the notes. If you weren't here, don't worry, I recorded it all for your viewing pleasure tonight to watch instead of your favorite Netflix show. So we have those two buttons in our calculator. We use the sine, cosine, and tangent. When we know what the angle measure is, that's what we feed in. If we want to know the angle, we got to use this inverse button. Okay, and one of the ways we can describe inverses in math is you switch the inputs and outputs. So normally we put in the angle and get out the ratio. And its inverse is flip-flop that. You put in the ratio and you get out the angle measure. Okay, so those are the ones we're going to look at today. So this first one says, use a calculator to find the measure of angle P to the nearest tenth. All right, here's angle P. I have a right triangle here. I can't use Pythag. Pythag gives me side lengths. And I don't know what angle Q is, so I can't do like 180 minus 90 minus angle Q. I have two unknown angles here. So the only way to find this is by using trig, SOHCAHTOA. So I always like to write out SOHCAHTOA. And if I'm looking at the measure of angle P, I gotta flip back to see what colors I was using for the hypotenuse. Red. I know my hypotenuse is 19. That's given to me. And this side, which is 13, is given to me. Is that my adjacent or opposite side? Adjacent because it's touching the angle. The opposite side is the side that it doesn't touch. So this is the adjacent angle. Okay. So using the acronym SOHCAHTOA to help us remember, if I know adjacent and hypotenuse, A and H, which of these three am I going to use? You can shout it out. A and H. Cosine. Cosine. S stands for sine, C stands for cosine, T stands for tangent. So how we would set this up is we would do the cosine, and then next goes the angle measure. The angle measure is what we don't know, so I'm going to use big P. That's what I'm trying to find. The cosine of the angle measure P is, okay, so this is what this also helps you remember, the ratio of the adjacent to the hypotenuse. So the adjacent side is 13 to the hypotenuse, which is 19. Okay, the ones we solved last time, my unknown was in the ratio. This time my unknown is in the angle. So to solve this, to find the measure of angle P, you use the inverse button and you feed in that ratio. Okay, so let's try this together on our calculators. So we hit second cosine, so it should have like that negative first power. That negative first power notation means inverse. And then we put in the ratio 13 over, I like to use the division symbol, 13 over 19. Close that. Hit enter. Since I'm using the inverse button, that means my answer is the angle. That's what we're trying to find. Obviously, this should make sense. My angle measure shouldn't be like a negative number or a number greater than 90 in this case. So the measure of angle P, round to the nearest tenth, 46.8 degrees. That's all we had to find. Okay, got it. So when you want to know the angle measure, you got to use inverse. Let's try one more like that. This time they want us to find the measure of angle D. to the nearest tenth. So angle D is this one down here. And I want to see what's given to me in this right triangle. Again, my hypotenuse is given to me. My hypotenuse in this case is 23. But this time, the given side is not the adjacent side. It's the opposite. That's my opposite side. 16 is my opposite. It's not touching it. All right. So looking at what's given to me, O and H, which of these three am I going to use? So, sine. Yep, because I know opposite and hypotenuse. That's how you decide. If you right away recognize you don't know the adjacent, that eliminates those options. Okay? We could find the adjacent side if we wanted to by using Pythag, but why create extra work? Use the information that's given to you. So now this is sine of the angle measure, which that's what we don't know. Sine of angle measure D is a ratio of the opposite side, 16, to the hypotenuse, 23. Okay. So here, when my unknown is stuck like inside the sine argument in the angle, that's a brand new pen. Oh, man. Thank you. I think she's still okay. Oh, no. Oh, my gosh. This is not good.
She's okay.
We're good? All right. We got to use inverse sine. Feed in the ratio. Okay, rounded to the nearest tenth, I got 44.1. Okay, makes sense? It's not too bad. That was kind of the only extra new thing we had to learn. Now we're just going to do a couple problems where they ask us to solve the triangle. Anytime you're asked to solve a triangle, you basically just have to find any of the sides or angles that are not labeled for you. Oh, by the way, this is a right triangle too. Draw a no right angle. I forgot to put that in. Okay. So there's no labels. Let's go ahead. When I label triangles, I usually do capital A, B, and then I always put angle C as the right angle. Another reason why I do this is because across from side A, we use little a. Across from angle B, we use little b. And across from side C, we use little c to represent the sides. And then the Pythag is nice a squared plus b squared plus c squared for us. Okay, so looking at what's given to me, I know side A, I know side B, and I know angle C. So I like to set up a little template for myself. I need to find side C, and I need to find the measure of angle A, and I need to find the measure of angle B. That's what I need to find. When it asks you to solve a right triangle, you got to find all the unknown sides or angles. Okay, what do you guys think would be the easiest to find first? Alejandro? Side C. How? Pythag, right? If you know two side lengths, specifically here we know the legs squared added together equals my hypotenuse squared. Okay, we could do this pretty easily. 20 squared plus 21 squared is 841. So square root both sides. C is 29. If you want to write that in your picture, you can. We should probably label this in inches. Okay, that wasn't too bad. Now to find the missing angle measures, I'm going to need to use some trig here. And I always tell my students, in case you make a mistake when solving something, try to stick with the information that's given to you. So what I mean by that, let's just say we're going to find angle A next. If you're going to find angle A, and you're going to use SOHCAHTOA, one of your trig ratios here, try not to use the hypotenuse because that's technically math we did on our own. So if you would have made a mistake there, you're kind of double whammying yourself. You're going to make a mistake then when you're finding angle A. All right? So if I want to find the measure of angle A, I'm going to use the opposite side because that was given to me. And I'm going to use the adjacent side because that was also given to me. Okay, I'm going to use the opposite and adjacent sides. And you could have found angle B first if you want. Doesn't matter. Okay. All right, so if I want to use the opposite and adjacent side, which of these three am I going to use? TOA, tangent. I don't want to use a hypotenuse because technically I did that math on my own. So I'd set this up. The tangent of angle A, that's what I'm trying to find, that's my unknown, is equal to the ratio of my opposite over my adjacent. All right, so again, we have a situation where you don't know the angle measure. So I'm going to use the inverse button. And I'm going to feed in the ratio. Yeah, I got 46.4 degrees. Okay. There's a couple ways we could find angle B. I just kind of gave you the spiel of like, try not to use your previous answer. But here, after you know two of the angles, the easiest way to find the third is that these have to total 180. So if you get to that point, that's okay. Don't work harder, like work smarter. Even if you made a small mistake, I'd still give you some partial credit for recognizing like, oh, to find the measure of angle B, I just got to do 180 minus the right angle minus angle A. You could also set up another trig ratio if you want to. You could set up the tangent of B is 20 over 21 and do it the same way if you wanted to. It's just a little bit more work. I'm okay with you doing this last step using your previous answer, 43.6. And then you can just box this as your final answer because there's all your missing side and angle measures. Okay, any questions? Isn't it fun? It's like a puzzle. All right, we got one more. This is another right triangle. Go ahead, draw that right angle. Let's label it the same way. A, B, C. Cross from A, little a, cross from B, little b, cross from angle C, little c. Okay, so now I'm creating my list of what I need to find. Looks like I need to find side A, side B, and angle B. This time, what would be the easiest to find right away?
Angle B.
Angle B, for sure. These have to total up 180. I mean, you could just do 90 minus 25 also, right? Because these two have to total 90. If this one's a right angle. All right, so 65 degrees. Okay, so I'm looking at A and B, and I can't use Pythag because I don't know the two legs. And I can't use a special right triangle like an S, 2S, S right 3 because I don't have a 30, 60, 90. It's close to a 30, 60, 90, but I can't use like a special right triangle. So I have to use trig. Okay. So again, use the information given to you. So I'm going to use angle A was given to me. And so was the hypotenuse. Okay, Walker, what do you want to find? Side A or side B first?
B.
B? Okay. If I'm using angle A, what is side B? Is it my adjacent or my opposite? Anybody? Adjacent. It's touching it. Adjacent. Okay? You guys have SOHCAHTOA memorized yet?
No.
Keep writing it down. I don't just accidentally memorize it. All right, so I know the hypotenuse. I know the angle measure this time, and I want to know the adjacent side. So I need a trig ratio that has A and H in it. Cosine. All right, so this is the one like we did before today. What day? Monday. Cosine of the angle measure, 25 degrees, equals a ratio of the adjacent side, that's what we don't know, we call it B, to the hypotenuse, 13. This time my unknown isn't the angle measure, so I'm going to just use the normal cosine button. And I told you to kind of think of this as like an equation. Try to think of this as you're trying to solve for B. So how do I undo dividing by 13? I'm going to times both sides by 13 to get rid of that. And B is 13 times the cosine of 25 degrees. So I don't use the inverse button. I just use the normal one because I know what the angle measure is. Oops, I guess I got to do this. So I get calculator. You want to take 13 times the cosine of 25 degrees. 11 point, you can round that to 11.8. Okay, now there's a couple ways we could find side A. We could do Pythag now if we wanted to, but that'd be using our previous answer. So I'm actually going to set up just another trig ratio. So if Walker would have said, hey, let's find side A first, the only thing that would have changed is instead of trying to find the adjacent side, we try to find the opposite side. Yeah, so which trig function would I use for that? Careful, I know the hypotenuse. So opposite and hypotenuse. Try not to use the one that you calculated, okay? So I could set up the sine of 25 degrees is equal to the opposite, which is A, the ratio of the opposite side to the hypotenuse. All right, so we can solve this. 13 times the sine of 25 degrees, and you get about 5.5. Okay, now you should check and see if your answer makes sense. So obviously your hypotenuse should be the longest side, right? It's across from your largest angle. What's my next largest angle besides the right angle? 65, angle B. So side B, the one across from that angle, should be your next largest side. Is that true? Yeah, it is my next largest side. And then across from my smallest angle should be my smallest side. So that's how you can kind of check and see if your answer makes sense. One last thing I want to show you guys on your calculator. I don't know if my 7th hour said they didn't know this. So I do want to show you, like say you wanted to use side B and then use Pythag. You can do that. That's fine. But what you try not to do is use 11.8 because that's technically like a rounded answer. Right? If you go back to what we actually got, it was that big long decimal. So there's a way in your calculator to use that exact number. So you actually use, I'll show you this button in a second, the answer button, and it'll feed down that exact answer. Okay. My hypotenuse is 13 squared. So if I wanted to use this previous answer, you can do that. Just try not to use the rounded one. And we do this like all the time when you take like some upper level math classes, because you constantly have to keep using stuff to like move forward in your steps, and you can't round it until you get to the end. So we use this button all the time. So what I'm going to type in my calculator is 13 squared. I'm going to minus this over, and then I'm going to a squared equals yada yada yada, and I'm just going to square root it. Okay, does that math make sense? So I would do 13 squared. There's my hypotenuse squared. So I'm going to minus, all right, here's how you would type it in your calculator. Parenthesis, and then right above the negative sign, you see the ANS. That means it's taking your previous answer. So you hit second, and then you hit the minus, and it'll feed down that exact number. It won't round it. It'll feed down the exact number. Close that. That has to be squared. Okay, so that's That's coming from here. 13 minus that. So we hit enter. Whoop. And then we just square root that. And that should be the exact same number as what we just got by using trig. Right? Like that 5.49, yada, yada, yada. So you can do that. But you have to use the exact. Notice if I would have used the rounded, it just would be a little off. Like if I did 13 squared minus 11.8 squared, and then square rooted that, it's like 5.45, which is close, but it's not exact. All right, so you can use your previous if you want to. Just try not to use the rounded version to be the most precise we can be. I thought there was one up here about precision. This one, attend to precision. That's important in math. Okay, any questions? We're done with my favorite lesson of the whole year.
Yeah, this is like
So fun.
among all the things that you have bored me with.
Yeah.
This is probably the most
The most what?
the most